Wake up. Wake up. All right? Experts are not necessarily what you think they might be. You become an expert in this world by working closely with the pharmaceutical companies. And if you don't, you are by definition not an expert. And therefore, everything you say can be dismissed as being the rantings of some idiotic zealot who doesn't like anything about medicine or something. There's a group in Oxford University who hold all the data on cholesterol-lowering medications and statins specifically. They hold all these data and they will never let anybody else see it. And they produce these papers in the Lancet on a regular basis saying how wonderful statins are. And we say, can we see the data? And they go, no. I'm not a conspiracy theorist, I'm a conspiracy factist. Because I have facts to back all this up. The reality is, these guys do not have, unfortunately, your best interest at heart anymore.
When it comes to health, how do we begin to decipher what is true and what isn't?
Anything written in a major medical journal should be treated with great suspicion. It's difficult. I've had people ask me this question many times. I was giving a talk in Aberdeen University where I went to university to study medicine, and amazingly, some professor asked me to come and give a talk to the students. And one of the questions was, how do you decide if a paper is valid or the research is valid? And in part, I sort of referred them to Fats Waller when a woman asked Fats Waller, tell me, what is jazz? And he replied, if you're going to ask, you'll never know. And there's an element of that about it, which is there is intrinsic and extrinsic knowledge. I don't know if you're aware of the terms. Intrinsic knowledge is something you gain over years and years and years, which is very difficult to explain to people what it is. I think that there are certain areas that are not contentious. I was just out in a meeting in the US actually this weekend called the Broken Science Initiative, where we are looking and a number of people are looking at how we can try and bring science, whatever exactly that is, back from a place where it currently is, which is an awful lot of it is of very poor quality. A huge amount of it is biased for various reasons, including commercial reasons, and somehow or other we need to try and recapture what science is from where it has got to, and that's very difficult for the average person, because the average person wants to believe that if they read a scientific paper with 10 professors of whatever, that this must be some form of objective truth. Sadly, it's very difficult to believe that that's the case anymore. That's by way of a preamble.
Well, I think for most people, going all the way to the journal is a stretch. Most people are going to tend to tune into an expert who they assume has read the journal and distilled that information down in a way that they can understand. So there's so many different layers to it. The very top, I would say, would be a scientific journal, at least conventionally speaking, that people would look to for top grade evidence. And again, that would depend on the type of article, and we could get into that, the different qualities of science. But in a practical sense, most people aren't going to go to the journal. So let's get practical for somebody out there who wants to get healthy. And even if they tune into a show like this, there's so many conflicting opinions and different ways of approaching health. What do they do?
Well, I think I would have said 40 years ago, 50 years ago, maybe 30 years ago, yes, read a journal. Read. Well, in my world, which is the medical research world, read the Lancet or the New England Journal of Medicine or the British Medical Journal or the Journal of the American Medical Association, and or just read an article by a journalist saying this article has stated the following, and therefore, we should do the following, and that would have worked, I think, reasonably well, but. Unfortunately, I think Eisenhower called it the industrial something complex. I call it the medical pharmaceutical complex. Has kind of taken over an awful lot of research. That's not true everywhere. There's sort of some basic research going on, which is done by very good people. I mean, I don't want to make it. I don't want to give the impression that there is no research that you can believe anymore, because that would be nonsense. Obviously, the majority of research papers are quite valid and are done reasonably well. But when you move into what I'd call contentious areas, and I think we know what they are. You would say nutrition at the moment, and diabetes, and things like the keto diets and the paleo diets versus the standard opinion by the mainstream journals. The use of medications in these areas. I think you have to, you can see that there are areas where there is great contention. I mean, for example, I was just looking at Alzheimer's disease. Now, not everyone. It depends on your age. Once you reach my age, Alzheimer's was more of a thing. I start forgetting stuff and thinking, well, am I getting Alzheimer's or am I just forgetting stuff? My current view is I've learned so much stuff over the years that in order to learn something else, I have to forget something else. It has to fall out one side. If it's going in that side, it comes out this side. So I can't remember stuff I used to remember. And that's my excuse. And I'm sticking to it. But with Alzheimer's, I mean, it's a huge area. Obviously, if you could come up with a drug that stopped Alzheimer's disease in its tracks, then you would be making billions. It would make the obesity drugs look like nothing, because people are terrified of it. It's a terrible disease. It costs huge amounts of money. Some time ago, they've done research on the brain, and when you get Alzheimer's disease, your brain shrinks. We know that, and it also develops things called amyloid plaques, which you may or may not have heard of. Amyloid is a form of protein that specifically, you can get a thing called amyloidosis, which is a horrible disease, which about 1 in a million people get. But amyloid plaques were identified as being probably the things that were causal for Alzheimer's disease. In other words, the more plaques develop, the more Alzheimer's you got, the more your brain decayed, the worse things got. Now, that original research on amyloid plaques was actually falsified, just made up. There are amyloid plaques in the brain with Alzheimer's, but it's not a causal link. And so they developed all these drugs recently to reduce amyloid plaque buildup in the brain, and some of them have stopped amyloid plaque buildup completely. And they then made these claims that this has had some impact on the progression of Alzheimer's disease. Well, this is actually just not true at all. I mean, even to the point where the FDA, which approves almost everything, has started to go, this doesn't really work. But you'd have heard on the news maybe a month ago, breakthrough drug, and all these patients standing up going, it's fantastic. And all the patients' relatives going, my father was getting worse and worse and he's taking this drug. And well, it makes no claim that it improves Alzheimer's, so they couldn't have got better. But they're now saying, oh, well, he would have been so much worse if he hadn't taken the drug. And you go, well, how do you know that? You don't. And essentially they haven't worked, or they work to such a minute, impossibly irrelevant degree that they're no good. And yet still you're hearing all this hype about them. So how can you know that it's hype? Well, you can't probably, because as you say, the average person reading a clinical paper will make no sense of it whatsoever. And then you say, well, who the hell else should I listen to? Then that's a very difficult one, because if you're me and people like me and people that I speak to who are very, not the word cynical, or is that the right word? I don't know. Anyway, we look at medical research and go, that's rubbish. All right. That is just nonsense. Don't pay any attention to it. Is that we get attacked. We're called conspiracy theorists. We're told, well, how can you know anything about this disease? You're not a neurological researcher. You're not somebody who's an expert in the area. And look at these experts in the area. And you're going, I know they're all experts in the area. Do you know why they're experts in the area? It's because they all get paid vast sums of money by the pharmaceutical industry to run these trials. And by running these trials, they get it into the major journals. They get their names known. They become asked to become on the guideline committees. They become the experts. You become an expert in this world by working closely with the pharmaceutical companies. And if you don't work closely with the pharmaceutical company, you are by definition not an expert. And therefore, everything you say can be dismissed as being the rantings of some idiotic zealot who doesn't like anything about medicine or something. and you're just dismissed. And if you try and get an article into a journal, forget about it. It becomes this horrible self-fulfilling prophecy. I was talking about, there's a group in Oxford University who hold all the data on cholesterol-lowering medications and statins specifically. And they also, the same people, and they do a thing called the Cholesterol Treatment Trialist Collaboration. They hold all these data from all the clinical trials, and they will never let anybody else see it. They won't let anyone else review the data. And they produce these papers in the Lancet on a regular basis saying how wonderful statins are. And we say, can we see the data? And they go, no. Well, just no. No, you can't see it. I mean, when I say this to people, they go, I can't believe that. And I go, I know it's difficult to believe that something as important as the clinical data from a major clinical trial covering drugs that are taken by more people than any other on earth, that you can't, the only people that can see these data are a group in Oxford who now run multi-million, hundreds of millions of dollars worth of clinical trials on cholesterol lowering on behalf of the pharmaceutical industry. The same people. And so, I mean, how can you say, it's very difficult. People don't want to know that actually it's not what you think it is out there. This is not some disinterested pursuit of the truth. I mean, it is in some areas. I was out in Phoenix at this conference with people, and we were talking about astrophysics. People were, not that I understand anything about astrophysics or cosmology, but and in their area, there is no vast amount of money involved. I mean, if you say I don't believe in dark energy, and someone says I do believe in dark energy, or I do believe in the multiverse theory, or I don't believe, these are just debates they have within themselves. No one's going to get rich or poor by saying, well, actually, I don't believe the unified theory of gravitation works with antimatter or whatever it is, because it doesn't actually commercially matter. I mean, their problem with science is just people talking rubbish. Our problem with science is people are deliberately keep passing out messages to support the sponsors of the clinical trials, and the sponsors are making billions of dollars out of them saying the things that wish to be said. So, where do you start? Well, I think you have to start by accepting somewhere that expertise is wonderful. Experts are not necessarily what you think they might be. In fact, in my field, is the man who almost invented or set up evidence-based medicine. It's an American professor from McMaster called David Sackett, who I met a few times, a really, really great guy. Absolutely 100% not a chance this guy would ever have, done any of this. But he wrote a paper 25 years ago now, basically saying a plea for the retirement of experts. He said, once you've been considered an expert for 3 years, you should be officially got rid of, because you're just getting in the way of advancement. Your ideas become too important, and no one dares to criticize you. And then he left the area that he was an expert in and never wrote, peer-reviewed, edited, or joined a committee on that area ever again. And you feel, of course, the supreme irony is, of all the experts in all the world, here's one who should not have retired or been got rid of. All the rest of them, frankly, yes, I mean, it's a kind of slightly a tongue-in-cheek proposal. But the reality is, these guys do not have, unfortunately, your best interest at heart anymore, if they ever did. But they certainly don't anymore. So if that's a kind of start point, does that sound like I'm ranting and raving or not? I don't really know.
If you're enjoying this episode, let me know by clicking like and subscribe below. Thank you so much, and now back to the show. The challenge with this expert piece is that all of us rely on experts and need to a point. You mentioned space there. There's not enough time in the world for any of us to take on all the different subjects we want to at least have somewhat knowledge in. And for me and you, we go deep in health and And every day my mind is blown and there's new things I'm learning, even though I'm so immersed in here, let alone space, let alone finances. Like we could go on and on. So what I'm getting at with this is the challenge is we need to rely on experts to get that knowledge, at least in a way that we can function day to day within these different categories we need to understand to function as a human.
Yes, of course. I mean, I wouldn't, I have particular areas that I would consider myself to be immersed in, and in fact, I have quite a lot of things to say to other people about. But if someone said to me, I'd like you to have a look at this paper in rheumatoid arthritis, I could do, but I would then have to read quite a lot of the background of everything around that paper, right? What is the current thinking? What's the research that's been done? What exactly are the drugs supposed to be doing? I would be looking around. It would take me a long time to read one paper in rheumatoid arthritis. I could grab an awful lot more than most people could because of reading in the background. But you're right. It is. I think people must, in that case, say, are there dissenting views? Are there people? Can you find stuff where someone like, say, me, or and there are plenty of others in the cholesterol statin world? Can you find dissenting views? Can you look at them? And I wouldn't suggest necessarily going to Wikipedia, for example, because unfortunately, I got booted off Wikipedia along with about 7 or 8 other people at the same time, and told that I was a crank and a lunatic and a whatever, because there was a few others that I know at the same time were removed. We know from the background who did this. And therefore, people dissenting views in controversial areas. So if you looked at something like, I don't know anything about climate science, all right? I know nothing about climate science, really, in any detail. I know what the arguments are. I understand that in detail. And there's the establishment view, which is that man-made CO2 emissions and methane and whatever are raising the Earth's temperature and causing whatever it is that they're supposed to be causing, and that this has been proven. I think in the areas, there's a phrase that I always makes you suspicious. It's when someone says, the science is no longer in any doubt, all right? At which point I say, well, whoever said that, they're not a scientist. Because if the science is not in doubt, it's not science, all right? It must always be in doubt. And when others say the vast majority, or they come up with something saying 98% of climate scientists agree with the current theories on climate change, I start saying, I look back at what Albert Einstein said at one time when 100 physicists wrote saying that his ideas on general relativity were nonsense. Signed Professor. And he turned around and said, well, if I'm wrong, it only needs one. And you have to present the arguments. There's no point in attacking me and saying, well, everyone else says this, so because you're not saying it, you must be wrong. Once you start seeing arguments like that, you think that there's more here. And in fact, the moment I start seeing all the experts agree argument, it raises an alarm bell in my head. I mean, you never hear someone saying, all the experts agree that the Earth is not flat, all right? You've never heard that, have you? No one's ever said that. You've never heard it. You've never come across it. Well, why not? Because it's just not an issue. And people say, oh, there's a flat Earth society. There is no flat Earth society. This is the actual existence of people who are saying there's a flat Earth society. Go and find the flat Earth society and go and speak to someone who believes the Earth is flat. Find me that person. All right. I have never found that person. I put out requests for it. And people use this as an example. But the example I'd use in reverse is, it's so obviously wrong, instantly wrong, that you don't have to have all the experts gather together in a big conference and go, this is true. The Earth is actually an oblate spheroid. It is not flat. We don't have that sort of thing. I mean, in my world, in the cholesterol world, you have conferences where they bring together experts from around the world to create a consensus statement is also another thing you ought to be very concerned about. Why do you need a consensus statement? This is basically the way to crush the opposition. We, the great experts from around the world, have gathered together, and we will state with absolute confidence X. Well, actually, all I need you to do is show me the data and the science, and if it's good, fine. And if it's not, no, it's not fine. So don't start trying to beat people into submission. So once you get a situation where people are trying to be beaten into submission, right? And whilst I talk very, very rarely about vaccines, for obvious reasons, that I don't want everyone to think you instantly get told you're an anti-vax nut. Even if you say one thing, say one thing, which is, I don't think there was adequate safety trials about the SARS-CoV mRNA vaccines. I don't think they were adequate, all right? You're an anti-vaxxer. I'm not an anti-vaxxer. I'm not a pro-vaxxer. I'm not on anything to do with vaccines, except I'm an evidence person. And if you can show me the evidence, I'll go, fine, thanks for showing me that. I've changed my mind, all right? But just going, you're an anti-vaxxer, you're a conspiracy theorist. Not only do you not believe that cholesterol causes heart disease, you're an anti-vaxxer as well. No one should ever believe anything you ever say about anything ever again, because you clearly understand nothing about science, and you should go away and hide and then think about the error of your ways and come back and cringe to us all and tell us what a terrible person you are. I mean, that is not scientific debate, is it? That is bullying. That is trying to crush opposition. And so when you see these sort of things happening, whenever you see these things happening, and you see them happening more and more nowadays, then you ought to be looking, I think you ought to be asking yourself a question. Hold on. What's this guy saying? What's he actually talking about? I remember with HIV, and I've forgotten his name now. It'll come to me in a minute. The man who actually discovered retroviruses. So he knew what he was talking about with viruses. He was a world expert, possibly heading for Nobel Prizes. Oh, it's annoying me. I can't remember his name. But anyway, he said that there was no HIV, human immunodeficiency virus at all. And that AIDS was caused by other things. And that AIDS wasn't really a diagnosis. It was just a gathering together of symptoms and blah, blah, blah. And he got absolutely blasted through the floor, all right? I mean, you can't, the stuff he was being accused of being a Nazi. I mean, he did actually have some slightly weird, pretty extraordinary right-wing views about things. But again, what does it matter? I don't care. For science, it doesn't matter if he's whatever he is. If what he's saying is true, you can't don't listen to him. He's a Nazi, God, I'll get his name. It'll come to me before the end of this. And I just started reading his stuff, and I thought, well, this is interesting, And I'm not sure if I believe it or not, but I'm having a read, okay? And in fact, he wrote an article there used to be a journal called Medical Hypotheses. Well, there still is a journal called Medical Hypotheses, which is run by Bruce Charlton, who I know vaguely. We communicated from time to time. And he published an article on the HIV, or AIDS is not caused by HIV because HIV doesn't actually exist, and blah, blah, blah. And then was such an outcry that basically the editors were kind of rushing around and went, we must apologize instantly for the nonsense. And then told him that the Medical Hypothesis was not a peer-reviewed journal. Oh my God, it's not a peer-reviewed journal. I said, well, how can you peer-review a journal called Medical Hypothesis where people come up with new ideas? This is an idea that no one has ever thought of before. And I would like the peers who have already got this idea to review the sense or otherwise of this idea. It was complete nonsense. You couldn't really have a peer-reviewed journal about new ideas, essentially.
Which you can extrapolate that into the problem with the journals in general. And you talk about this in your book, the peer-reviewed process. Generally, the people that are peer reviewing are going to have a consensus on what they think. And if you come in with a new hypothesis, they're going to just push it aside and not publish you, possibly.
No, why not possibly? Absolutely, plausibly. I mean, yes. I mean, the peer review process is held up as some sacred process of scientific verification. It's absolute rubbish. If it were up to me, I would get rid of peer review entirely on the basis that I've been asked to peer review a lot of things, and I do some peer reviewing. But the process itself, there's a very famous article published, and it's going back again about 20 years, where somebody wrote in the methodology section. Now, papers consist of a terribly formulaic, really boring way of writing. A title, an abstract, an introduction, methodology, actual findings, discussion, or however you decide to put those things together. Now, the methodology section will be something like, we use the ZY5 spectroscopy set to 53 millihertz, blah, blah, blah. No one ever reads that. It's totally boring, all right? But actually, within one of the papers in the methodology section, one of the professors wrote, if you read the sentence and phone this phone number, I will send you a free crate of champagne, all right? And he never got a phone call. And obviously, the editorial people had just taken the whole section and repeated it. The peer reviewers are clearly, no one had ever read this. No one ever read it at any point, all right? So essentially, you can put any stuff in there you want. It's quite extraordinary. Yeah, the peer review process, I was reading a paper, I've just been pulling a paper apart for this thing, the Broken Science Initiative. I'm writing some articles for them. And I'm looking at a paper, and I've just written to the authors, although the authors never write these papers. That's another thing. Professor so-and-so, Professor so-and-so, Professor so-and-so, Professor so-and-so. They've probably never seen the paper in their life. They just want their name stuck on it. It'll have been written by a medical education scientific company on behalf of the pharmaceutical company. It'll be waved in front of them, and they're going, yeah. That's fine. That's my 300th paper today that I've just apparently written. And they've got a figure wrong. They've missed out the number of people by 1,000, or if you add the figures together, right? I was sitting there going, 892, 643, 8,723, and whatever. And I thought, they're missing 1,000 people. They're not there. They've just disappeared. I haven't had a reply. This is about a week ago, and I've written them saying, I looked at figures ABC and whatever. There's 1,000 people. It seems to be missing 1,000 people. It doesn't seem to be. It is missing 1,000 people. I've double checked it with a couple of other people to make sure I'm just not going mad. And that makes a huge difference to the results of this table and the paper and its conclusion. I mean, and it has other things. I was reading it on the basis of it was designed to lower LDL cholesterol. It's one of the new LDL cholesterol lowering drugs, which it did by about 60%. But within it, it has weird things. Normally, whether I should become specific, about 85% of people who have cardiovascular disease or die of cardiovascular disease die of a heart attack or myocardial infarction or a stroke. That's 85%. That's pretty standard. World Health Organization, whether you believe the World Health Organization anymore, which I'm beginning, sadly, to doubt even the World Health Organization is not biased. Anyway, no one argues with this figure, all right? And in this study, what they found was that actually only 15% of people died of myocardial infarction or stroke, and 85% of people died of something else. It doesn't specify what this something else is. And I'm sitting thinking, well, there's a few things you can die of. You can get an infarction in your bowel. That's like a blockage of a blood vessel. That's dying of cardiovascular disease. You get an infarction in your kidneys. You can get a few other things, but they're relatively small and sparse and in between. All right. And then so we have this study, and they've gone, in this study, 85% of people died of something else. And they won't tell you what the something else is. I'm going, if I was a peer reviewer of that paper, I'd go, you chose a population for the study who'd already suffered a myocardial infarction, right? Heart attack, whatever you want to call it, same thing-ish. And so therefore, they were far more likely to have another myocardial infarction. That was the most likely thing to happen to them. And yet, of the cardiovascular diseases that they died of, actually, no, not died of, but suffered events, the vast majority suffered something else, and you won't say what that is. Now, had I been a peer reviewer, which no one's ever going to ask me to be a peer reviewer of a study on cardiovascular disease, actually they do. I would have gone, well, how the hell, what's going on here? This is nonsense. And the other thing that in the study was, normally 35-ish% of people who have a heart attack, myocardial infarction, die, right? 65% survive. Okay, fine. But the majority of people who die before they reach hospital, right? So whatever you did in hospital, you could never, even if you got every single person who arrived in hospital with a heart attack to survive, you'd still have a mortality rate of around about 17%. Well, no, that's never going to happen anyway, right? Because you can't, unless you're bringing them back to life in hospital, which seems unlikely, you're going to have this death rate. Now, in the study itself, they had 640 myocardial infarctions diagnosed, all right? 640 myocardial and 30 deaths, which is a mortality rate of 5%, okay? And I'm going, I have never seen any mortality rate ever. I mean, it doesn't exist, right? You can't have this figure. It doesn't exist. 5% mortality rate for myocardial infarction. The normal is 35%. Even if you were saving every single person that came into hospital, which couldn't be possible, that was still alive at the time, you would still be getting 17 or 18%. I go, right, well, where the hell does that figure come from? As once you start, I mean, as a peer reviewer, you'd be going, come on, guys, what are you doing here? I don't believe these figures. These figures are clear nonsense, all right? These are fabricated figures. They are fabricated figures, all right? It'd be like saying, most people are 6 foot tall, but in our study, everybody was 35 feet tall. Really? Where do you find 35 feet tall people? Well, in our study, they were 35 feet tall. You think maybe you're measuring them wrong in some way. They weren't really 35 feet tall, were they? I mean, it was so ridiculous. The figures in this study are so ridiculous. They're so out of kilter with any research that exists. There's no research that matches this at all right? And yet, it's gone straight through. Of course it's gone straight through, because it's gone into the New England Journal of Medicine. The number one impact journal, medical journal in the world is the New England Journal of Medicine. Now, why is it the number one journal? Because the number of people who cite the articles counts, all right, basically. So if you're writing an article and you use references, and most people generally go to the top 10 journals in the area or whatever, and then cite them. And if you cite them, that goes back to the NAJM and says, you've been cited. So your impact factor, in other words, the impact factor being how often it's cited, how often is it quoted. There's various other parameters, but basically it's how big a splash has this article made in the world of medical research. NEJM is number one, Lancet's number two, BMJ, British Medical Journal, 3 or 4, JAMA, 3 or 4. I mean, these are non-specialist journals. Obviously, in oncology, I'm not sure which one's the top in rheumatology, with the International Journal of Rheumatology or whatever. And then there'll be, the North Korean Journal of Rheumatoid Arthritis. It's probably got an impact factor of 0 up to whatever it is. So there's all these other factors and parameters. But obviously, everybody fights to get their things into the highest impact journals. So if you want to make a big splash, you get it into the New England Journal of Medicine or the Lancet or the BMJ or whatever. And then these are the things that then feed down to the journalists, because they're the things they look at and they go, oh my goodness, there's been a study here. And the PR organizations churn out press reviews and they fire them at all the news outlets. And the next thing is, embargoed until 001 on the 12th of July, and then bang, and it all fires out. And then suddenly you'll get it on the news the next day. It'll be researchers find whatever, researchers find new drug cuts the risk of heart disease by 45% or whatever it is. And that's where people get their stuff from. That's where most people get their stuff from. Whenever I see an article suggesting anything is super beneficial, I go, that's not true. That's just not true. Or not true in the word that true would mean to you or me, all right? So, for example, Lipitor, which is atorvastatin, is the number one selling statin ever. It's made something like $200 billion profit over its lifetime. The GDP of the entire continent of Africa, probably. And they advertised, the big advert that really sold it or swung it for them was they had an advert that said, Lipitor reduces the chance of heart attack by 36%. All right. And that sounds pretty wonderful. I've got a 36% reduced chance of having a heart attack. That sounds like you would be absolutely insane not to take Lipitor, wouldn't it? I mean, crikey, you're heading towards a half or something. And I know I looked at the paper it came from was actually called ASCOT. Yes, ASCOT. There's so many stupid acronyms. And of course, then I looked at the paper and thought, well, what's the paper really found? What did they really find? Let's go through it. And what they've done is a thing where they looked at the total number. Let's put it another way. Out of 100 people in this study, if 100 people had taken the placebo, right? See if I can get these figures right off the top of my head. 97.9% of people over 5 years would not have had a heart attack, right? That's so therefore, whatever it was, 2.1%. Now, 3.1% would have had a heart attack over 5 years, all right? And in the group taking the statin, 98.8% of people would not have had a heart attack. So that's the difference between the two groups of 1.1%. Absolute difference, all right? 1.1%. But the difference between 97.7 and 98.8 was 36%, because that's what it is. If you multiply it, I'm trying to make sense. I'll make it a simpler example where I know the figures, but this is a made-up example. You have 200 people, you split them into two groups of 100, all right? You give one of them a placebo, one of them a statin. At the end of however long your trial is going to last, which is another thing they never talk about, because obviously if you have an effect very quickly, that's beneficial. If you had to wait 10 years, it's less beneficial. But they never tell you that figure. Anyway, so you wait 5 years. At the end of your trial, 2 people out of 100 taking the placebo are dead, right? And 1 person taking your drug is dead. So the difference is 1 death versus 2. Okay, that's 50%. So that's a 50% reduction in mortality relative. 2 versus 1, 50% relative difference. 2 versus 1 is 98% of people are still alive versus 99% of people are still alive. The difference is 1 person. So that's the absolute difference. 1 more person was alive at the end of the trial. That's a 50% reduction in relative risk. Does that make sense?
Yeah. So what you're getting at here is something you really address in your book, relative versus absolute risk.
It's absolutely.
And how with relative risk, you can't really do anything with that number as you're showing here.
Yes. Well, say you do the same trial with 1,000 people, right? And at the end of that trial, it's a different trial. At the end of that trial, 2 people die in the placebo arm and 1 person dies in the treatment arm, whatever the treatment is. The difference is still 2 versus 1, so it's still 50% reduction in risk. But as an absolute reduction, it's 0.1%. If you did it in 10,000 people, it'd be 0.01. If you did it in 1 million, it'd be 0.00001. The relative difference remains at 50%, although the absolute difference has shrunk to almost nothing, all right? So what they do when they report trials is they report them on relative risk difference, all right? Which sounds big, 36%, all right, sounds like a big reduction. In reality, it was a minute reduction. But the other thing that they do is that they don't tell you something else. And this is the other thing I say to people. If you want to ask a question ever of medical research, well, especially in this area, is what are you not hearing, all right? What don't you hear? You've heard about heart attacks, that's fine. Now, you're going to assume there that a heart attack, if you don't have a heart attack, with 36% less heart attacks, a 36% less chance of you dying. That's the implication. That's what most people take this to mean, all right? But that's not what it means at all right? Because in this trial, the absolute difference in fatal heart attacks i.e. the ones that kill you, the absolute difference was 0.0000. Right? There was no difference in the absolute number of heart attacks, fatal heart attacks. As for overall mortality, which is the risk of dying of anything, which is another thing you want to know, if I take this medication, will I live longer? All right? That's the question you should ask. Doctor, if I take this drug for 5 years, how much longer will I live on average? All right? And the answer for this trial that showed a 36% reduction in heart attacks, the answer to the question, would I live a day longer, is no, you would not. There is no evidence that it increases your life expectancy by 1 day. All right? Now, I think that's quite important. But no one asked this question. Doctors don't ask it. By the way, I'm talking, you're saying, how does the average person on the street, come to terms with this? That's not really relevant because doctors don't understand this either. I have never yet had a single doctor that I have asked the question, what is the difference between relative and absolute risk? I've never had a single one of them be able to explain it to me. Ever. And these are the people that are supposed to be telling the public, oh, yes, statins are wonderful. I've asked the question on doctors and doctors forum and said, how much longer do you think you will live if you take a statin for 5 years? Right? I've asked this question in different formats because there are many different ways of asking this. Some doctors go, about 2 years. Right? So a lot of doctors out there think if you took a statin for 5 years, you'd live an extra 2 years. The evidence from the clinical trials is you won't live any longer at all if you haven't already had a heart attack or stroke. So they're overestimating the benefit of statins by infinity. And that's what they're telling their patients. Infinity is the benefit. Well, infinity versus the reality, all right? So there's no point in asking your doctor, what do you think I should take? Because the doctors don't understand medical research either. They just don't. I'm sure there are doctors involved in clinical research. There are epidemiological doctors. There are people who understand this stuff. There are some of them. I know I know doctors I could speak to and we could discuss absolute relative risk and all sorts of different things to do with outcome measurements and blah, blah, blah. And they would have no trouble understanding that. Ask your average family doctor or cardiologists don't understand it either. They just don't understand it. They asked them, I'll get the figures wrong, but I do discuss it in that book, Doctoring Data, where they did prostate cancer screening and said that prostate cancer screening, I'm going to make this figure up, but it was because I can't remember exactly what it was. Prostate cancer screening reduces the risk of dying of prostate cancer over the next 5 years by 40%, right? Which sounds absolutely fantastic, and anybody should do it. And absolutely wonderful and marvelous. But actually, the actual figure is something like you will reduce the risk of being dead in 5 years by 1 in 20,000, right? And those two figures, whilst they sound utterly different, are the same, just presented in a different way, package them up differently. I'd look at cervical cancer screening, and the figures from that were even more extraordinarily I think you had to screen 65,000 women to increase the 5-year survival rate for one woman with cervical cancer screening. And people look at you and they go, well, that's just wrong. It's just wrong. And, I haven't got the figure. I don't carry these figures in my head, but I wrote them in the book, Doctoring Data, and you can work them out, all right? And you can say, they're not wrong. These are as far as we know the figures that exist, all right? So you're going to say, well, who are you going to believe? All the experts telling you must go and get screened, or some raving lunatic on a hill going, really? Is it really bad? Because the other thing with screening is I think in the book, and I've used this case many times, is a woman saying, I was screened. I was told I had breast cancer. I had a breast removed. I got, infection and problems with my lymph nodes, and it was horrible and terrible. And now I feel terrible. It turns out it wasn't breast cancer at all. Because the false positive rate of screening for cancer is very high. Well, higher than compared. Was this sensitivity specificity? People are so terrified of missing cancer that they never, ever want to say to somebody, you're all right, you're clear, you don't have cancer. And it turns out they do, all right?
I would assume a big part of the problem with everything we're talking about right now is when the media gets a hold of some of these relative numbers and starts amplifying them out. CNN, Fox, the New York Times writes an article, and then those are going to be another step down where people are just going to read maybe the headline of the relative risk. And I could just see how the further, it's like that telephone game where the further you pass the message on and it gets diluted down,
Chinese whispers.
It's going to change over time and then be less valuable.
The journalists don't understand. Let's face it, there are one or two, give them their due, who understand some of this stuff anyway. But yes, the figure. No one wants a thing saying, if you screen 56,000 women. By the way, it's pretty close to the figure if I recall off the top of my head. If you screen 56,000 women, you may prevent one case of cervical cancer death. People are going to go, shit, really? That can't be true. I've heard. It's this thing of I've heard. Where do you get your ideas from? Well, you're bombarded with the same ideas again and again and again. It all sounds wonderful. At one point, Switzerland, amazingly, they didn't do it because they lost their nerve. We're going to stop doing breast cancer screening because the benefits were so marginal to negative that they realized it wasn't worth doing. Now, in fact, I knew this stuff, right? There was a guy called Peter Gooch, that's how you pronounce his name, who sets up the, whether you've heard of it, Cochrane Collaboration is a group of scientists around the world who do reviews of treatment, and they didn't used to be funded, but now they are. And if you're going to get an unbiased or objective view of the evidence, they're probably a good place to go. Right? They present it in a way that they use an outcome measure I don't like, but it's better than the ones the pharmaceutical industry use. Right? And that they tend to use the thing called number needed to treat. So it's how many people do you need to treat with doing this for one person to gain a benefit? So obviously the lower the figure, the better. So an NNT of 1 means everybody who gets this gets a benefit. Well, that's fantastic. An NNT of 1,000 means 1 in 1,000 people will get a benefit, right? Now, it has its flaws. Again, it's time correlated, because if you give an antibiotic for a week and someone's cured and your NNT is, say, 2. So for every 2 people you treat, 1 person gets better. It's better than that with antibiotics. But that's fine. If the time it takes for that is a week, that's fine. But if it takes 20 years for you to have an effect, obviously that effect is enormously diluted. They never talk about that, all right, which I think is a weakness, definitely. So how long do I have to do it for? 60 years. Well, and here's one that I can take for 5 days. Which one are you going to choose? So they don't look at that. And anyway, there is no way of presenting medical outcomes that is anything other than flawed, if you like. Because however you present it, you have to sort of also discuss it around it, because it's, in cancer treatments, they use increase in median survival, right? So they say, if you take this cancer drug, and they'll do a trial for 2 years, and what they say is at what point, and the median means it's not the same as the mean or the average or the mode or anything. And again, you're running into this thing of people just going, oh, he's talking about statistics. Oh my God, I'm going to run away. Look, put it this way. If you take a cancer drug for a year, all right, your increase in median survival may be 6 months, say. All right. The increase in median survival being how much longer, just about, it's not quite, we'll say it is. How much longer would you expect to live if you took this drug for a year? 6 months, okay? That's the increase in median survival. That's quite a good method. But of course, if after a year, the curve goes like that, and everyone who lasts a year then is cured and treated, all right, then the median is not anywhere near the mean or the mode or anything else, all right, because you've actually treated people. So all the people are going to die in the first year, and then after that, the curve does this. That's not very likely, but that means that the median is not the same as the average, is not the same as blah, blah, blah. However, in cardiovascular treatment, they never tell you, they never establish this figure, all right? Because in a cardiovascular trial, it's never going to last, it has to last for about 30 years for 50% of the people in the trial to die. Whereas in a cancer trial, a lot of them would be dead in a year. All right. So you can say, how long did it take for 50% of the people in the trial to die? That long. What was the difference at that point? And they can use that as a median survival. And there are people in cancer treatment saying we don't like median survival very much because it doesn't look very good compared to cardiovascular trials where they go 50% reduction in cardiovascular or heart attacks. All right. And they go, we take the drug for a year and you get an extra month. And go, that doesn't sound really very good, does it? So they don't like presenting it that way anymore. They'd rather present it the way cardiovascular disease works, all right, because it sounds much better. And then people will want to take the drugs much more often, all right? So it's, and then you can get, you get the relative risk, you get the absolute risk, you get the median increase in survival, you get RMST, reduction in mean survival time. There's millions of ways of presenting this, all right? And most people have no idea about any of this, and I understand that. I wouldn't say, here's your 6-month course in statistical analysis of clinical trials. But your question of for most things, if say you're taking a drug for diabetes, or you're taking a drug for lowering your blood pressure, or taking a drug for cardiovascular disease or whatever, then you're taking a drug for the rest of your life, basically. And people should ask the question, and you're not going to get an answer to this because no one knows the answer to this question. But I know the answer to this question, and some people do, but nobody else does, which is, how much longer will I live if I take this drug for the rest of my life? All right? Now, none of the clinical trials have lasted for the rest of anybody's life, so we don't really know for sure. So what you do is most of the trials maybe have lasted 5 years. Now, at the end of 5 years, you could say, well, let's just extrapolate. If you get an extra month in 5 years. After 10 years, you get 2 months. And after 15 years, you get 3 months. We don't know this because we don't know what happens. I mean, if you did a clinical trial in smoking and you got people to smoke at the age of 20, by 25, nobody would have died of lung cancer. All right, well, maybe one would have done or something. So you could say cigarette smoking is entirely safe and it has no adverse effects and no one dies of lung cancer. You go, yeah, that's true. However, you probably need to carry on the trial a bit longer, didn't you? So when you have clinical trials on certain drugs, you could say, well, if they're causing adverse effects that gradually increase, then actually the benefit would disappear. And in fact, you'd die younger if you kept taking it. Now, we don't know that for sure, all right? No one can know these things for sure. So you're always left with these variables about answers. Anyway, but going back to your question again, if we get back to where it is, how does the average person ever know? All right. Well, I think what the average person needs to do is to say to themselves, okay, I'm hearing this. What are they not telling me? What am I not hearing here? What would I like to know? All right. There's no point in going and asking your own doctor or your cardiologist or your diabetologist about their drugs for diabetes. I mean, the biggest trial, well, that wasn't the biggest trial, but there was a trial called Accord. Yes. Anyway. It may not be called Accord, where they got people and they tried to drive the blood sugar level down as low as possible. So if, say, at the time, if your blood sugar level was averaging, or what you call your HbA1c, they've got that in the States, which is not your blood sugar level, it's your average blood sugar level over the last month. So they were saying, at the moment our target is, whatever it was done, 7.5. But we wanted to get it down to as low as we can. So they gave all sorts of drugs. They gave insulin and glucoside and metformin and everything else they could find and piled it in until they got to reach this point, 6.5 in this population. They had to stop this study early because the people whose blood sugar levels were being driven down the most died the quickest, all right? They died earlier and quicker and they're just dead, all right? So the idea was the more you can get the blood sugar down, the better it was. Well, the more they got the blood sugar down, the higher the mortality rate was. And that was published. And of course, the usual people came along and said, oh, well, it's not because the blood sugar level was reduced. There was other things that caused it. Right. You don't know that. All you know is that if you try and do this, it doesn't actually have the benefits that you thought it was going to have. All right. And I've seen many studies on blood sugar lowering that are very scary to me, especially when you combine what you call, I don't know if they even use them so much anymore in the US. There's all these new ones coming along that are now being used to lower people's weight, all right? And these are now selling vast amount. I haven't looked at this area in any particular detail. You know, these new, what they call Zymegas and Ozempics, and I don't know what they're called in the States, that are actually glucagon inhibitors, and they reduce appetite and they stop people eating and their weight goes down, and all is wonderful. All I'm going to say is, I'm seeing things that are making me go, this is looking very worrying. I am worried by these drugs now. I would not be surprised. Nothing would surprise me less than if we find that we are doing some really unpleasant things to people's physiologies with these drugs. There's already osteoporosis showing up and all sorts of things. I mean, it's being suppressed. The research is not being done properly. But I'm picking up, you know, these things that go beep, beep, beep in the background, and you think, hold on, it's not quite as wonderful as you might think it is. In fact, frankly, giving millions and millions and millions of people these drugs and just handing them out like Smarties. Anyway, I don't know that, all right? I'm looking at it now. I've decided it's my latest area of what am I not being told? Because the other thing I'm hearing is nothing is too good to be true, all right? These drugs are being sold as they're just too good to be true, all right? Not only are they diabetes drugs, but you also lose weight. The whole world is now saved. Fantastic. I mean, apart from the fact that the entire budget of the entire health service of the entire world is going to be spent on these drugs in a not too distant future, which is always a worry. There are some worrying alarm bells going off around about these things. So I would not be surprised, you know, I would not, and you need to look at this stuff for yourself, all right? And I know it's a pain in the arse and you wish you could believe the experts, but you can't. And if you do, you're stupid. Not in every area, all right? But there's plenty of areas of medicine that are just straightforward. There's no conflict about it. You know, do you need a hip replacement? You need a new hip. You're in agony and you can hardly walk, but you get a new hip and then you can walk around. You know, I don't need a clinical trial. I don't need a clinical paper to tell me these things work because I see these people all the time. All right, it's a fantastic operation. Yes, some of them won't work. Yes, the operation is going to kill a few people. Yes. But you know what? On average, I have no question in my mind that these are good things to do. But when we're coming to mass medication of people for the rest of their lives, where pharmaceutical companies are making billions and billions and billions and billions in profit, look at these things closely, all right? And whilst all the experts will be saying, yeah, take them all, it's fantastic, you can take everything you want as long as you want, and there's no possible adverse effects, and people who say there are adverse effects are just conspiracy theorists who should be squashed and put in jail or whatever it is that was supposed to happen to us now. Look at them very closely, because whenever I look at them, you know, when I look at this stuff, it's worrying. What are the benefits? And the first one I looked at was blood pressure lowering. Because outside of statins, I think more people take blood pressure lowering tablets than any other form of medication in the world. I'm going to stick my neck out and say that's still true, all right? And yes, most of these drugs are no longer on patent. In other words, it's generic manufacturing of these medications. So actually, all this stuff happened 30, 40 years ago. You know, this is when all the new blood pressure lowering tablets were coming out and the pharmaceutical companies were pushing them. And I look, the first ever blood pressure lowering trial where they looked at people with what you call nowadays hypertension, systolic pressure 160 or whatever it is, and diastolic 110. If you had that nowadays, they'd be rushing you in the hospital with blue light flashing. But when you go back 40 years, that was considered mild to moderate blood pressure, hypertension. Right? And they used drugs for this, and they used it over 5 years, and there was 19,000 people in the trial over 5 years. If you're going to see anything, you'd have seen anything. And the reduction in heart attacks was there was no reduction in heart attacks. a reduction in stroke was something like 7 less strokes in the treatment arm. The overall mortality was that there was no difference in overall mortality. The overall cardiovascular mortality was there was no difference in cardiovascular mortality. I was at a meeting where this was presented, 1989, I think it was, in the UK. So in fact, they set up an entire department to run this study. It was such a big thing. It had never been done before. And I sat in this study and thought, well, that was rubbish, wasn't it? And everybody else just went and they just wrote it down. And I thought, excuse me. It was, I think Winston Churchill said once, occasionally a man may stumble across the truth and then picks himself up and carries on as if nothing had ever happened. I felt like I was in one of those parallel universes, red pill, blue pill. I took the red pill and thought, what? There is no doubt that having a raised blood pressure is a sign of an underlying problems and you are more likely to die of cardiovascular disease. True. That does not mean, however, that lowering it is necessarily beneficial to the same level as it increases the risk. That's probably never going to happen. But I didn't think the benefits would be so small as to be what a waste of time benefit level, which is, in my opinion, what it was. But people that the weird thing that happens is, of course, once you've shown that lowering the blood pressure, they focused in on the stroke issue and said, and it was a relative risk reduction. If you take blood pressure lowering medication for 5 years, it reduces the risk of stroke by 30%. Right? You mean 7 people out of 18,000 over 5 years. I said, for that to get benefit, for one person to gain benefit, you'd have to be alive for 9,740 years or something. It was just, to me, it was just like, no, that's just not worth it. Can we not get some better, benefit than this? And then, of course, once you've proven that, then it becomes unethical not to give blood pressure lowering medication for people with high blood pressure. So you can't do a placebo-controlled trial ever again because you are potentially harming people who are not taking the medication. So that's it. So the only medication trials after that have been these medications versus those medications versus these medications versus those medications. And so you actually don't know anymore what the benefit would be for this drug versus taking nothing at all. This drug benefit versus taking that drug benefit, but that drug benefit was almost zero. So what are you actually getting at here? And they're almost all non-inferiority trials now, which is you say, is our drug actually as good as rather than is it better than? And they say it's as good as and it's cheaper or whatever. So you're in this situation. I was, again, reluctant to talk about vaccination, but there has been no placebo-controlled vaccination study ever done, ever. All right. The only studies that are done are one vaccine versus another vaccine versus the other vaccine versus the vaccine that was here previously. But you keep going back in time and you say, well, have you any evidence that was better than, or the safety was better than placebo, or the efficacy was better than placebo? You don't have these data. So you were presented with this cast iron fantastic benefits, and you go back and you think, yeah, but it was all based on nothing at all to start with. This is, again, go back to blood pressure. So, we have millions. I think half the population of the United States is now considered to have high blood pressure, hypertension, because the level that you treat at has come down and down and down and down. When I started in medicine, it was 160 systolic and 110 diastolic. It's now, for some populations, it is now you're considered pre-hypertensive if you have a blood pressure of 130 systolic and 85 diastolic, which incorporates 75% of the adult population of the United States. 75% of the population of the United States has got a disease that needs to be treated. Right. Now, if you believe that, well, you can believe it if you want. You can go and take tablets for the rest of your life if you want. You know what benefit you're going to get? The benefit's going to be mind-bogglingly small to non-existent, and possibly over years and years of taking a drug, actually, you're going to cause harm. Because we know that elderly people, and I deal with elderly people a lot, one of the commonest problems they have is that they get what they call postural hypertension, and then you fall to the ground and then you break your hip. And then once you've broken your hip, your life expectancy after the first fracture of a hip is 9 months. All right. And quite often it's 0 months because the operation will kill you. For repairing your hip as an emergency operation. So falling over because your blood pressure is low. Because increasingly I get people who, they're on 5 blood pressure lowering medications simultaneously. It's like, what? Well, it's because the GP, in my case, family doctor in your case, is prescribed drug X. The blood pressure hasn't fallen because they're not taking it, right? Because it makes them feel horrible. And so they put them on another one, and then they put them on another one, they put them on another one. And they go into hospital and they go, my God, their blood pressure is still high. We better give them another one. So when they're in hospital, they get given all 6 of them or 5 of them or whatever it is, and their blood pressure goes like that. Then they fall over, then they break their hip, and then they die, right? This is, or they get constantly, we find people who, because a lot of these blood pressure lowering tablets interfere with your kidney function. A lot of them interfere with your sodium and your potassium. So you end up with either hypo or hyperkalemia and hypernatremia and hyponatremia and God knows what all. And then some people die because their sodium level drops so low that they just die. So these drugs are not, they're not like safe. In fact, they're not even remotely safe, okay? They are quite damaging and to take over year after year after year, but that's it. You take them year after year after year after year. And if all this, if all this stuff was working, if all this medication, all these guidelines, all these medications that people are taking now, all right, compared to when they used to take them, if all this stuff was actually having fantastic benefit, what we would expect to see in the Western world, in the US, the UK, would be that life expectancy would be increasing. Would you not? You would think, well, we're taking blood pressure medication, we're taking statins, we're taking blood sugar medication, we're taking long-term this, long-term that, long-term everything, all right, for years and years and years. And what's happening is, as you know, and anyone who's looked at this, is life expectancy in the US is falling. Life expectancy in the United Kingdom is falling. All right? So if all this preventive medication, I mean, in the UK, we have a system, it's just completely mad. It was nearly a hill upon which I died, but I didn't die, was a thing called QOF, which is Quality Outcome Framework, which is all family doctors, all GPs were told, here is a list of millions of things that you're supposed to do for your patients. You're supposed to weigh them, you're supposed to check their blood pressure, you're supposed to check their cholesterol, you're supposed to check whether they've got diabetes, you've got to check this, that, and the next thing. There's 100, they keep changing it, there's 112 indicators. And you get paid money for achieving any of the indicators, including lower their blood pressure from year to year, lowering their blood cholesterol from year to year, lowering their blood sugar from year to year. And so there's 1,040 points that you can earn. And if you earn 140, if you earn 1,040 points, your practice gets however much it gets, about a third of your total income, actually. So it's a big thing. It's cost, since it's been introduced, it's cost, I think, $60 billion, $100 billion. It's been going on for quite a while. And whenever anyone's looked at it, and some people have looked at it and said, has it had any benefit? The answer is, we can't see that there has been any benefit whatsoever from doing this. There is no health benefit that we can see, all right?
We've gone deep to this point into the flaws within the system, within the research, the corruption, the manipulating of numbers. What really gets me frustrated with all this, well, a lot of things, but one of the big things is the fact that somebody like you comes along with a different hypothesis or way of looking at things, and you're taken off of Wikipedia. So how is science supposed to move forward? And how are we supposed to continue to better medicine if we don't allow new ideas to come in and challenge the current paradigm? To me, that is just so frustrating.
My approach is not to tear my hair out by the roots, storm government with pitchforks and flaming torches. But there are times when I think, what else? The public, until the public goes, shit, there's a certain point where People just put up the stuff, and they put up the stuff, and they put up the stuff, and the system is fine, isn't it? And then until suddenly, I would have thought this point would have been reached by now, but obviously it hasn't. Which is, wake up, wake up. All right, but unfortunately, the control of the media has increased, and with COVID, it really got very bad, and it hasn't got any better. It's not got any better since. These sort of ways of silencing people have become widespread, universal, and also, I mean, if you go back many years, there was German medicine. I mean, German medicine had actually blood pressure increasing tablets they gave people if they thought their blood pressure was too low, for example. And then there was British medicine, there was American medicine, Japanese medicine, Chinese medicine, South American medicine, and people were doing different things and discussing things differently. Now, because of the internet and the globalization of everything, the ideas have become globalized. So if you went to speak to a cardiologist in Japan or Germany or Britain or the US, they would tell you exactly the same things about everything. All the guidelines have become worldwide guidelines. They're not the guidelines for every country, but the thinking, the processes, there's no dissent. There's not even a possibility of in Germany, we've got these people who got together and decided X. All right. No, because they won't decide X in Germany anymore. They'll just go along with everything. So, of course, dissent in that situation has to be almost deliberate. Well, it's not deliberate exercise. I mean, I don't go around going, all of medicine's terrible and you should forget about it, or live in a cave and eat grass or whatever. There's many things about medicine that are fantastic, just absolutely fantastic. Operations, anesthetics, antibiotics, hip replacements, there's no point in going on about that, all right? I would be dead if it wasn't for medicine. I had a ruptured appendix. I had it taken out. I'm alive, right? Had modern medicine not been around, I'd be dead. Boo. So, I'm not here saying everything in medicine is rubbish, because that would be ridiculous. But we are in a situation whereby it's going wrong. And it's going wrong, and dissent and argument and discussion. As you may know, I'm involved in a court case in the UK, the result of which is coming out in the next 10 days, I believe. Right? I've heard that before. Basically, the Mail on Sunday, which is the biggest circulation Sunday newspaper in the UK, and actually worldwide, it's got a huge circulation worldwide because they've managed to get an internet presence. It's very, very successful. So they reach all around the world. Basically, put out an article saying that because I was saying that cholesterol didn't cause heart disease and that statins weren't wonderful, I was endangering thousands of people and probably resulted in the deaths of thousands of people. To which I said, right, well, I'm not having that. So we're suing, myself and someone else, are suing the Mail on Sunday and for libel, defamation, whatever. And hopefully we can win. We should win, but who knows? And at that point, I will be free to be even more outrageous about things than I am now, as people say. But we need, the fact that they attacked me and two others, and I'm not going to name their names because it's not because it's not known. It's just that they don't. I don't know what they once said, but I know what I once said. I'm not going to put words into their mouths for me. But I was 11 years ago. I was speaking to an Australian producer called Marianne Damasi, who was running programs called Catalyst. I don't know what the equivalent would be in the US. It was kind of scientific programs, an hour on do fertilizers cause brain cancer or something type of thing. Anyway, she did two programs, one on related. One was saying that saturated fat doesn't raise cholesterol and doesn't cause heart disease. And the second associated article was that raised cholesterol doesn't cause heart disease, and that statins have more adverse effects than most people, whatever exactly the articles. The program said have more side effects than people are normally told. And she was severely attacked. Now, I helped her for these programs. I was in the behind the scenes telling her the questions to ask. I said, you do, and I've kept the emails, you do realize you're going to be attacked for this. She was attacked. She was told because of her programs that people had stopped taking statins and thousands of people had died as a result. She lost her job. She was booted out of the Australian Broadcasting Corporation. They tried to rescind her PhD by saying that she'd falsified data, which was complete nonsense. They tried to crucify her, all right? And they did. Now, she's still around, and I still speak to her, and she's now a kind of independent journalist who writes about broken science and the ridiculousness of it all. In Australia, there's a orthopedic surgeon called Gary Fetke, Tasmania, who was saying, fed up of operating on people and they can't lose weight because it's not helping in these operations that I'm doing. And he said people should not be eating a high carbohydrate diet. They should be eating a low carb, high fat diet, kind of Atkins, paleo, whatever you want to call it. For which he was told, dragged in front of the Australian Physicians Association, severely censured and told that he could never, ever write or talk about this subject ever again, even if it was proved he was correct. All right. He nearly lost his license to practice. There was a Swedish GP, God, the names escape me, but it'll come to me, who was attacked for saying the same things in Sweden, and they tried to remove her license to practice medicine. She was accused of killing millions. Uffe Ravneskov, who started the International Network of Cholesterol Skeptics, had his book burnt live on television when he said The Cholesterol Myths is his book. Tim Noakes in South Africa, who used to promote high-energy sweet drinks for athletics. People, he was well known in that community, realized that actually he was talking nonsense and changed his stance to being a lower carbohydrate, high-fat kind of guy. He was attacked and dragged to court 3 times by the South African Physicians Association, who tried to remove his license to practice. And I can give you stories again and again. And we were attacked, and it's exactly the same. Michel Delorgeril, a very famous nutritional scientist and professor of cardiology, who did the original Lyon study, which showed benefits of, in quotes, Mediterranean-type diet on heart disease. He's been attacked and silenced in France. And so when the attacks happened in the UK, I wasn't very surprised because, there's a pattern emerging here. Every time you say saturated fat doesn't raise your cholesterol, or whether it does or not, it doesn't matter because it doesn't cause heart disease, you get attacked by the low-fat food manufacturers. You take on statins, you get obliterated by the pharmaceutical industry. Is this a worldwide conspiracy? Well, it doesn't need to be a conspiracy because they all get. It's not. Depends what you think a conspiracy is, and I hate the word anyway because it's just a ridiculously lazy way of silencing someone. You're a conspiracy theorist. Well, what is the conspiracy that I'm theorizing? Who's in it? Who have I said is in it? And what are they supposed to be doing? How are they doing it? And they don't answer these questions. They just go conspiracy theorist. I'm not a conspiracy theorist. I'm a conspiracy factist because I have facts to back all this up. There was a Belgian journalist who got attacked. He tried to write an anti or a critical statin article and was told by his editor never to write on this subject area ever again. All right. It's so these things have happened, and they're true. You can go and look them up if you want. Kilmer McCulley, he decided homocysteine was the cause of heart disease, not cholesterol or whatever. And he was publishing away. He was working in Harvard. He got booted out of Harvard. Right, couldn't get any research grant, and Harvard started phoning up any university he had an interview with to say, do not employ this man. Now, that was published in the New York Times. This is not a conspiracy theory. This is not making stuff up. These are facts. You can go and check them yourself. They're in my books if you want to read about them. So it's, where at what point, though, I know there's a piece of elastic, which is credibility, okay? And if you stretch the elastic this far, people will kind of go with you. You stretch your elastic this far, people can't go with you. You stretch your elastic this far, snap. They go, this guy's just a conspiracy theorist. He's talking conspiracy stuff. Well, that's why we were having a meeting in Phoenix, Arizona last week, Broken Science Initiative. Scientists who are very worried about the state of science. Bruce Charlton, what does he call it? Which you remember from Medical Hypothesis. He said, what we now have is zombie science. It's not real science, it's dead science. It looks like science. It's people wandering around in lab coats and stethoscopes and test tubes and whatever, but actually there's nothing happening here anymore. It's not science any longer. It's been infused with money. The results are predetermined. There's no one trying to find out new stuff. There's just people trying to prove their hypothesis were right. It was Isaac Asimov, he of iRobot fame and whatever, who said the most interesting thing you can ever hear in science is that's interesting, not eureka. The scientists around the world are now just going for eureka. They want a positive trial showing a positive result that what they thought was true is true. And when they find it's true, they go, look, we proved it's true. They use manipulation techniques with statistics that are just, now we're getting into real mathematical stuff I'm not even going to go into. But we have a thing called P less than 0.05, which is the probability of this being a chance result is less than 1 in 20. Right? At which point they go, it's true. Right? That's not science. 1 in 20 is true. And they do things what they call P mining, where they just go and find, is there any part of this study where I can find a probability that says it's true? This paper I was talking about earlier. Well, they now have a thing where they don't look at a single outcome like death or cardiovascular death or number of heart attacks or number of strokes. Or what they do is they get a combined endpoint. So they say, in our study, we're looking for a combined endpoint that includes cardiovascular death, heart attack, stroke, hospital admission with angina, revascularization procedures, which means putting a stent in. And we're going to combine them all. And all these things count towards our endpoint. All right. Now, this is in itself ridiculous because it suggests that someone having a stent put in counts the same as somebody dying of a heart attack. Well, clearly, no, that's not true. Certain things are more important than others. All right. And then what they do is obviously the thing that changes is the endpoint of having a stent put in, which is not a clinical endpoint, it's a clinical decision. I, as a cardiologist, decide you need a stent put in. Right? That's not a clinical endpoint. That's you deciding to do something. So, of course, when they do the trial, what you find is that the number of deaths from heart attacks in these trials was like 30. And the number of stents that was put in was like 960. Okay? And they add 960 to 30, and they go, oh, look, there was a statistically significant change in the combined endpoint of cardiovascular death, revascularization, and MI, not non-fatal MI or fatal MI. And you just look at this and go, this is just absolute nonsense. This is nonsense. But so long as they can go, probability less than 0.05, they can then get a headline going, fantastic success with the medication. So looking back at this drug, which is called Repatha, and the study was Fourier, and it's an injectable cholesterol-lowering drug. It was pronounced a success, this trial. The press releases were it's a success. It was approved by the FDA based on this trial, and now it's selling about $2 billion a year in sales for this drug, all right? And it was a drug that lowered your cholesterol by 65%. And the total number of cardiovascular deaths, and I think I can remember, the total number of cardiovascular deaths in the drug arm, the Repatha arm, was 251. Okay, and the total number of cardiovascular deaths in the placebo arm was 240. Okay, so it was 11 less cardiovascular deaths in the placebo arm of this trial. Okay, now you or I, or anybody in the world presented with that might go, well, that was a complete waste of time. Slightly more cardiovascular deaths in this drug that lowered cholesterol by 65%. Okay, It was presented as a success using combined endpoints. It is now being prescribed. And if you ask doctors about it, they go, they're wonderful, these drugs. They lower cholesterol even more and look at the benefits in cardiovascular disease. What you mean? And the total mortality was higher in the drug arm as in relation to the placebo arm. So, and yet you present this to people. But I present this to doctors, and it's like, whoosh. They're like, look at you like, did you say something? Yeah, what I said was, in this drug trial, more people died of cardiovascular disease taking the drug called Repatha than died taking the placebo. And in the statin, and they say, oh, it's lowering cholesterol is beneficial. Look at the statin trials. You say, well, actually, did you know? No one knows this. There were 4 drugs that were researched around about the turn of the millennium. They were called cetrapibs because that's the end name, which means you know that they are a cetrapib. There's 4 of them. One was torcetrapib, but the other ones I can't remember the name of. And they lowered LDL by the same amount as cholesterol, LDL cholesterol, bad cholesterol. And they increased HDL, which is good cholesterol, by up to 130%. All right. So you get a double benefit. You get high HDL, good protective HDL, low LDL. All right. So they should have been better than statins. All right. And the end result was the first trial was a 55% increase in cardiovascular deaths. That was torcetrapib. That was a relative risk increase. So the absolute risk increase was not huge. And the other 3 showed no benefit at all. So have you ever heard of these drugs? Well, maybe you have because you've read my books, but has the average person on the planet Earth, do they even know that these drugs existed? That they did things that were far more beneficial, in inverted commas, than statins. And the overall impact of these 4 medications was an increase in cardiovascular disease. Did you know this? Now, why did you not know this? Well, there's a very simple solution. Because no one ever said anything about them, except in very obscure parts of medical journals, which you can go and look at if you want. Because failure was silence and success was da-da-da-da-da. When they originally started doing clinical trials in blood pressure lowering and statins and all these things, there was no requirement for a company to say they were doing this study. So they could start it off, see that it failed, and remain absolutely silent about it. You never even knew it happened, right? And this happened quite a lot. So it's like tossing a coin, and every time you get a head, you go, heads. And every time you get a tail, you go, heads. Heads. Didn't you get 3 tails as well? Oh, no. Not that anyone knows about. I mean, literally. The guy that started the whole bloody ridiculous diet heart hypothesis and got it going is Ansel Keys. A very big name in cardiovascular world and still considered a hero to many. And he did, his hypothesis started with you eat cholesterol, your cholesterol level goes up, and you die of heart disease. That was his original hypothesis. He fed lots of people high cholesterol diet, nothing happened to the cholesterol, and so that hypothesis died. He changed it to if you eat too much saturated fat, your cholesterol goes up and you die of heart disease. Right? That's not science. That's just rubbish. But in the late 1960s, he got a study funded for millions and millions of dollars where he got people to change saturated fat for consumption into polyunsaturated fat consumption, basically oils and plant oils and Benical, well, it wasn't Benical, but any of those ridiculous things that you've heard about. And it was a study done on about 10,000 people over 5 years, and it showed that the more polyunsaturated fat that you ate, it did reduce your cholesterol level, all right, which, anyway, there's an explanation for that. But the more your cholesterol level fell, the greater the risk of dying of cardiovascular disease. This is a diet study. And the interesting thing about that study is that it was finished in 1973. It's called the Minnesota Cardiovascular Experiment, MCE. The interesting thing about that study is it was never published. They just didn't publish it. Why? Why didn't they publish it? And in 2015, there was a research group that were looking at trials that, there's a name for it, trials that were started and never finished or didn't report properly. It's got a name and I forgot what it is. Anyway, they go back and try and find trials that were done that nobody published. And one of them was speaking to someone and said, didn't your dad do a clinical trial in the 60s on this with Ansel Keys? He went, yeah. I said, if the data still exists? He went, well, I've got a garage full of magnetic tapes and all the data still existed. Amazing. These researchers went back, looked through all the files, got a hold of the data, however they did it, spooled it on, out-of-date machinery. And I went through the data and he said, you know what they found was they actually published the study in 2016. Was that 50, just over 50 years after it actually finished. And they showed these data, which was actually, the lower the cholesterol, the greater the risk of dying of heart disease in this trial. Never published until 2016. And when they had all the guidelines being done in the 1970s and 80s about diet, and we must eat more carbohydrates and we must stop eating fat, and saturated fat must be no more than whatever it was, 10% of your total diet. This study, which was the only study that's ever been done like that, would have completely destroyed all of those guidelines. All of the nutritional guidelines couldn't have existed had this study been published. And then in 1970, whatever it was, 8, when they had these first dietary studies that came out, all the data said, the data that existed, which was virtually non-existent, said, we should reduce saturated fat, we should increase carbohydrate consumption. And if you look at a graph of obesity in the United States of America, it goes along pretty flat line till about 1978, and then it goes like that. Okay, you can't prove causality through that for sure, but by God, it looks like causality to me. Is that they changed the dietary advice from, no dietary advice really, to eat carbohydrates and stop eating fat, and obesity levels straight lined up from that point. Straight lined up. So people did what they were told, amazingly enough. Never thought people would do such a thing, and look what happened. So we go back and say, is this a new phenomenon? Well, it's no. The phenomenon of science being driven by things. I mean, Ansel Keys wasn't a man who was interested in money, and he wasn't working with the pharmaceutical industry. He was just a man who was certain that he was right. And he had this idea and he fought and battled for it, which is kind of what you should do as a scientist. I absolutely agree. He was obviously a gigantically influential character. He was wrong, but he crushed the opposition. There's a guy in the UK, Pure, White and Deadly, who wrote the book. I'll come to me in a minute. And he said it's not fat that causes obesity and diabetes and heart disease, it's too much sugar. And Ansel Keys just obliterated him, and attacked him and told him he was an idiot and gathered all the forces of the American Heart Association behind him to smash this guy pulp. So it's not just money that does this. Of course it's not. It's reputation, it's status, it's all the stuff, Max Planck around about 1901 wrote, science progresses one funeral at a time. So experts they're not necessarily driven by money, although nowadays much more so than ever before, especially in medical research. It's also, they have ideas and they're absolutely certain about them. There's a Professor MacDonald in the UK who, is it MacDonald? It doesn't matter. He's absolutely staked his entire kind of world's reputation on salt is terribly bad for you and you must eat less salt and it lowers your blood pressure and blah, blah, blah. The evidence for this is it just doesn't exist, all right? The Cochrane Collaboration looked at salt intake and found that the difference that they could find in salt intake in otherwise healthy people was 1 millimeter of mercury, all right, systolic. Well, you couldn't measure that actually in an individual. If I took your blood pressure now and took it in 10 minutes time, it would vary by more than 1 millimeter. So for an individual, 1 millimeter of mercury is actually just the same thing, all right? So, but he, I wrote a couple of articles saying, salt's actually good for you and we should be eating more of it. And actually that's good. In fact, the NAHNE's Nutritional Something Society of North America, the huge nutritional studies showed that basically the less salt you eat, the higher your risk of dying. And it wasn't very big, but it existed. It was basically low salt eaters were the people who eat the less salt were the most likely to die, and the people who ate the most salt were least likely to die of anything. And of course, again, you say that to people and they go, that can't be true. And you go, well, go and read it for yourself, all right? And you say that to doctors and they go, whoosh. And then they go, oh, there's the other one, isn't it? If you, to avoid obesity, don't eat so much fat, sugar, and salt. Right? So how many calories does salt have in it? Precisely. I'll tell you precisely how many calories salt has in it. None. All right. And in fact, there's a very interesting article I read years ago saying that actually people need salt and they will be kind of monitor it because amazingly enough, our bodies have got this capability of knowing things like we're thirsty, we're hungry, we haven't got enough salt. Did you ever see that David Attenborough thing with parrots in South America? Where there's very little salt in the Amazon basin because it all gets washed away by the rain in the Amazon. So it's actually very low in salt. These parrots fly about 500 miles to get this little cliff place where it's got a lot of salt in it to bring it back to feed it to their young because otherwise they don't develop properly and they die. So they know what salt is. There's places in Africa where elephants go into these caves and smash rock off the roof of the caves. It lands on it. They eat it. Why do they eat it? Because it's full of salt. All right. And we're told salt's deadly for you. Well, it's anyway. But if you don't eat enough salt and your body says, there's not a thing goes off in your brain saying, I need to eat salt. But actually, we eat more food to get enough salt. So the more salt they take out of food, the more food we eat in order to get the right amount of salt, and especially if we're not allowed to put salt in anything. You go to a restaurant, I was out in the States, if you want extra salt on your food, they look at you like you're mad. Can I have some salt? Salt? That's white stuff, it's kind of crystalline. You have it in this thing and you do that in the morning. And I had boiled eggs, and I had boiled eggs for breakfast. American breakfasts are just ridiculous in restaurants. What on earth are they eating? Anyway, I had 2 boiled eggs and some bread. And I asked for salt. They were like, virtually, I think we'll have to call the police, sir. You're actually asking for salt. You do realize you're going to kill yourself. Just give me the salt. And I managed to get some salt on my plate so I could eat my boiled eggs and my bread. But, it's the same in the UK. They've taken salt off the tables. It's what? There was a guy that used to be very anti-salt alderman in the state, and he was the president of the American Society of Hypertension. Right? So he was pretty bloody mainstream. Okay, he was as mainstream as you can get. He was don't eat salt, don't eat blood pressure, blah blah. So he did a study on people with heart failure in hospitals, and he had one lot where he was severely restricted to salt, and the other lot where he let eat the salt. And he was trying to prove, because in heart failure is sort of most severe condition of having cardiovascular disease, really. It means you've already got problems in your heart, it's not working properly, your arteries are all clogged up, you've had a heart attack or two. So he thought, well, if it's going to be beneficial, this is going to be the group where it's going to be most beneficial, right? And so he reduced the salt intake in this group and kept it the same in the other group. And the mortality rate, this is a relative mortality rate, was 4 times higher in the people who were salt restricted. Right? 4 times higher. And he went, this salt restrictions thing, maybe we shouldn't be doing it. And from that point on, he became persona non grata. Bang. Wallop. Okay. And he's, just attacked by everybody in sight. They couldn't attack his research because his research, it's not a big enough study and it's done in New York and we can't say it works in Philadelphia because people in New York are different people in Philadelphia, blah, blah, blah. usual stuff. And he has written around about it. And you know, the reality is, if you look at salt restriction, and this comes from way back, there was a diet where you had no salt at all to lower your blood pressure. It was never white rice and bread. It was absolutely horrible. And the blood pressure did drop a very small amount. They never proved it achieved anything. But anyway, if you don't eat salt, your kidneys say, we better stop peeing out salt, right? Because we need it. And there's two hormones that actually trigger in. It's called aldosterone, there's renin, there's angiotensin. And they keep your blood pressure up if you don't have enough salt, right? And these two hormones, the renin, aldosterone, angiotensin system in your kidney is very clever. Releases hormones, narrows your blood vessels, makes your heart beat faster, blah, blah, blah. All these things that it does to keep your blood pressure up if you don't have enough salt. These are actually very damaging to your cardiovascular system. Potentially very damaging indeed. Because if you want to do anything with your kidneys is keep the renin, aldosterone, angiotensin system quiet. Because once that starts kicking in, you're firing up your entire cardiovascular system in ways that you don't want. Narrowing and tightening of arteries, speeding up of heart, increase. It's just not a good thing to do. So there's actually very strong evidence that would support not restricting salt in people too much. And yet this is still what we do. There's no evidence from any clinical study ever that people who take more salt die, get cardiovascular disease or anything. But the argument is, in some people, if you eat more salt, your blood pressure goes up a bit. And because your blood pressure is up a bit, you're more likely to die of cardiovascular disease. Whilst there's a very, very small increase in blood pressure, such that you would never measure that in an individual. The evidence, the second part of the evidence, which is, does it increase cardiovascular disease events or death, doesn't exist. And yet we have this, and Nahani's study, big study in Scotland, other studies that I've seen, reduce salt intake too far and you will actually do yourself considerable harm. All right. And yet we still have, but there's no commercial support for this hypothesis. There isn't. You think the salt industry would be going, eat more salt, they don't say anything. Or you'd think, there's nobody going, I'm getting rich by telling people not to eat salt. That doesn't exist. So it's not just financial pressures. Of course it's not, right? There are also fixed ideas in people's brains that you can't get rid of. Salt's bad for you, stop eating salt. Where did that come from? So when I say, how do people know this? Why would they believe what I have to write about salt, right, versus the entire rest of the medical profession? Well, I'm going to tell you 99.99999% of the entire rest of the medical profession has never read a study on salt restriction in their lives. So they're just getting it from where someone else is getting it from, or is getting it from where someone else gets it from. No one's ever gone back and gone, there's a book about vaccination called Turtles All the Way Down, if you want to read it. Don't read it if you have a nervous disposition. Is basically what they're saying is true, is it just becomes an accepted thing, The diet heart hypothesis from Ansel Keys. Where was the evidence? There's never been any evidence for it. 5 portions of fruit and vegetables a day. Where is the evidence? There's no evidence at all. There's never been any evidence to support this. You look at people and go, that can't be right. And you go, well, I'll tell you what, here's a challenge for you. Go and find the original study proving that 5 portions of fruit and vegetables is healthy, or does anything for you whatsoever, or is of any benefit to you whatsoever. Go and find that study. And if you do, let me know, because I've been looking for it for 35 years. And so have many other researchers, all right? Use another very simple example. HRT, okay, hormone replacement therapy. 25 years ago, it was in the guidelines from the American ACC and AHA to take HRT to protect against heart disease, all right? We now know it increases the risk of heart disease because a study was done. But where did the original idea come from? Where did the original idea come from that female hormones protected against heart disease? All right, you go back and you go back and you go back. What it comes down to is, what they found was that women get less heart disease in men age match. So at the age of 50, men have 5 times as much heart disease as women. At the age of 60, it's 5 times as much as well. But until you reach the age of about 50, women's rate of heart disease is very, very low. And then it starts to go up quite rapidly. Follows men by about 10 years in reality. Okay? So the heart disease rate of a man at 50 is the same as a woman at 60 and 60 and 70 is whatever. And so people said, oh, well, what's doing that? I said, well, what changes at that age? It's female hormones that change at that age. So once women lose their female hormones, they start to get the same heart disease rate as men. Fine. That was it. That was the reasoning. There was no other reasoning. There was no other facts. There was no other data. There is no other data. There's no data at all to support this at all. If you ask 100 doctors, what do you think protects women against heart disease? They go, female sex hormones. Guarantee it. Even though the study on HRT showed that if you give women female sex hormones after the menopause, they're more likely to get heart disease than if they don't. And any of the data that had ever been done up to that point contradicted the female sex hormone data. You couldn't find anything supportive anywhere at all. And yet it was entirely widely believed by everybody. All right? It still is believed by people around the world. You say to people, what causes heart disease? Oh, too much saturated fat consumption. Well, what country in the world has the highest saturated fat consumption? France. What country in Europe has the lowest rate of heart disease? France. Which country in Europe has the lowest saturated fat consumption or did? Ukraine. Which country in Europe had the highest rate of heart disease? Ukraine. Which country has the second highest saturated fat consumption in Europe? Switzerland. Which country in Europe has the second lowest rate of heart disease in Europe? Switzerland. These things never had any supportive data, and yet we're surrounded by it. So if I can refer back, because I know we're just about out of time now, unfortunately.
I want to respect your time, but let's end on this. We've talked about a lot of the corruption, the manipulation of data, and gotten to a lot of the negativity with a lot of the science. Let's come back to the practical piece and end on this. Given everything we've shared, what is the average person, given all this new knowledge, supposed to do to live within this current paradigm we've described?
Well, I think unfortunately, you have to start by questioning. Not everything. You can't read everything. You can't read every study. But I think you have to start being more skeptical about what you're hearing. And I would seek out. Well, I would say seek me out. Obviously, I'll tell you what to do. Seek out people who are promoting different views. And don't just dismiss them because they're promoting different views. Go and see what they're saying. And if it makes sense, go, right, well, maybe I'll find out a bit more. Because it's not, I'm not alone in this. There's people who've written malignant medical myths. There's people who've written about cholesterol. There's people who've written about diet and salt and all these things. And it's just open yourself up to the possibility of there is a different world out there of people who are trying to make people aware that a lot of what they're being told nowadays about the biggies in medicine, the biggies, heart disease and cancers and diabetes and obesity and diet and nutrition, that find people who are saying different things, look for them, make an effort, and if you don't believe them, you think they're talking rubbish. Well, fine, that's up to you. I can't sit here and say I'm right about everything. Of course I can't. That's stupid. I can say I've done my research and I've come to these following conclusions. Now, you may agree with me or you may disagree with me, but at least give me a little bit of your time. And if you think this guy's just ranting rubbish, or if you think, Marianne Demasai is ranting rubbish, or the people promoting, I would say, keto or paleo or low-fat diets or high-fat diets are talking rubbish, fine, but don't just dismiss them because the mainstream is dismissing them. Don't dismiss them because others have dismissed them. Dismiss them yourself, all right? Take a bit of effort and read it and go, right, that's just rubbish. This guy's talking rubbish. He has no idea what he's talking about. I'm not going to listen to anything he has to say because he's just an idiot, a conspiracy theorist, or whatever you want to say about me. That's fine. I'm saying different things, not about everything, but I'm saying different things about the big ones in medicine at the moment. I think are there, aren't they? Obesity, diabetes, heart disease, cancer, stuff like this is. I'm not an expert in cancer, but I know there's a lot of work being done in, say, high-fat diets and reducing carbohydrates and blocking carbohydrate synthesis in the mitochondria, which reduces cancer oxidation, and therefore your cancer cells can't develop so fast and blah, blah, blah. There's a lot of really good stuff out there on this, okay? And I'm not saying to people this is some miracle cure. But also perhaps ask yourself the question as well, what's this guy trying to sell me, all right? Or what am I trying to be sold here? And the people that you need perhaps to pay more attention to is saying, well, this guy, I'm not selling anything to anybody, all right? I don't have a supplement. I don't have a magical whatever. I don't have an antioxidant. I don't have anything. I have nothing. I'm not trying to sell you anything. There is nothing ever. I mean, people have accused me of this. Oh, I'm trying to what? Go on. What am I trying to sell? What I'm trying to sell? I'm trying to sell one thing to you. There's only one thing I'm trying to sell to you. It's called the truth as I see it. Now, that truth may be wrong, okay? But there's only one thing. That's what science is. It's the truth. It's a tyranny of the truth, all right? There's no bullshitting science. It's true or it's not, okay? It's right, it's wrong. And when people are selling you things that are making billions and billions and billions and billions, they have a clear incentive. The only incentive I have, and others that I could talk about, our only incentive is to try to improve the health of people by giving them the information that we believe to be true. All right? That doesn't mean people selling things are wrong. People have to make a living. I make my living by being a doctor. I don't need to sell anything, okay? And other people do, and I understand that. And it doesn't make it wrong to sell things, but you always got to say, if somebody's trying to sell you nothing, listen to them.
I'll end on this. I really like this piece of advice from Doctoring Data, where you say that we should approach ideas from 3 different angles: probable, possible, or unlikely.
Yes.
And to eliminate the black and white thinking, the absolute.
Yes.
And I think that's a good roundabout way of rounding out our conversation, and I really like that advice.
Thank you. I hope it's been helpful.
Malcolm, we're going to link up your books, your website, your social media, everything in the show notes, and thank you for coming back on.
No problem. Nice to speak to you again.
Now that you're done, you're going to want to head over here and catch this next incredible episode. You don't want to miss it. I'll see you over there.
There are no essential carbohydrates whatsoever. None. Zilch, zippo. Telling people to have at least 55% of their diet in the form of the one macronutrient that we don't even need is the starting point that's wrong.